am so glad to be back because I used to live here in Hamburg, and I'm glad that they let me back into the place. I've been living now in Amsterdam for a while, which is kind of like Hamburg, but the internet connection is better. So, yeah, today I will talk about GitOps, but it's like less of a technical talk and more focused on like the process of delivery and how we can invite non-technical stakeholders into the delivery process. So just quickly about myself, my name is Lian. I'm a developer advocate with Loft Labs. Has nothing really to do with what I'm talking about, but I have some stickers later that you can pick up if you want. You can find me on the Bird app at Lian Makes Things, or you can send me an email to LL, that's LL, not II, at loft.sh. And before I was a developer advocate, I was a cloud native consultant. So I helped companies transform their whatever servers running on bare metal into like something more, you know, like cloud native, like putting things into containers, putting things on Kubernetes, these kinds of stuff. And so the story that I will talk to you about, the story that I will tell you today, is from the time that I spent consulting. And so some of it is true, some of it is half true. All right, guess which? So I'm going to tell you the story of a company named Moneybank, which is not a real company. Moneybank was, they came to us to help them with their delivery. So I guess what happened was someone went to a conference, learned about GitOps, learned about Kubernetes, and they were like, okay, we have to do something Kubernetes. So they invited consultants, because that's how you do it usually, to come into the company and start that transformation. So when we started the engagement, usually what we do is we go in the company and spend about like 2 weeks maybe just talking to people and finding out like what's the situation there, what are their problems. We call that discovery, or I think now they call it cloud native assessment. And what we found was that in this company, they have about 200 engineers. And they have, as it is with most of these like bigger organizations, they have very clear hierarchies, technically. The hierarchies become less clear once you actually need to get stuff done, right? Like, it's like very obvious that there are levels, but then if the question becomes, okay, who do I have to talk to actually get this done, it's kind of less clear. And also because, as you might have guessed, Moneybank operates in fintech, which is just like a sector that we've seen exploding in the last couple of years. It's also a very regulated sector. So that was something that also was kind of at the core of this organization and of all their technical decisions. And now when we take a closer look at the engineering structure, what we see is that there are 3 different kinds of teams. There are product teams. So these teams are directly responsible for building the product that would be used by bank customers or the bank tellers. There were service teams that helped the product teams with delivering stuff. So that could be, for example, QA. That could be the office admins, the office IT. So they were just supporting the product teams. And then there were specialized teams. And specialized teams are a bit more, they're like kind of like service teams, but they're a bit different because they have such a specialized topic that they might not only provide a service, but rather they are kind of more about building like an entire thing. So as an example, security teams often can fall under service teams, but in this example, for the Moneybank organization, they were not really in service to the product teams, but they also decided on rules. So they were giving out kind of like the actual rules of how you had to deploy your products, your applications into the cloud or into Kubernetes. And also, but it wasn't just, you know, the application itself, but also kind of like, what's the security mindset here? Like, you shouldn't be, you know, I don't know, taking pictures of your door pass or these kinds of things. So that was all the security team. So that's why it's a bit separate. And if you ever read Team Topologies, which is a very well-known popular book, they go a bit deeper into this kind of structure of having these 3 kinds of teams. All right. So after the 2 weeks assessment, We came back, and we kind of decided that we found about like 3 things. It's always 3 things, because 3 is a nice number that makes like counting very nice and builds like a nice narrative story arc. So we found 3 things that we felt was slowing them down when they were trying to deliver software. One thing was quality assurance, and I'm not saying that quality assurance is a thing that slows you down, quite the opposite, but the way that they were doing it was that QA was its own team, and they did things in their way. They had their own cluster, they had their own way of delivering to that cluster that was completely different from how other people were doing it. Or maybe not, we just didn't know. We didn't really know what they were doing. So there had to be like really long and complicated handovers for them to like test things and then hand it back to you so you can like continue delivering your software. We also found that they had like very different environments. So the development environment and the staging environment and the test environment and the production environment, they were all completely different. For one thing, they didn't have containerization at that point. It was just running all on like, I want to say Tomcat servers. And as I said before, like individual teams had individual ways of doing things, so the environments were always completely different. And then finally, again, because everything was so regulated, compliance was a very important thing. And the way that they built in compliance into the delivery process was basically, there was a guy who had to sign everything in blood 3 times, and then it was okay to go to production. Which obviously, again, it's slowing everything down again, and it also puts like a lot of pressure on like one person who, it never was the same person for like more than 2 or 3 months at a time, because no one wanted to do that. No one wanted to put their name under it and just be like the poor schmuck that's like, it's all his fault, right? So these were the 3 main things that we brought to them, and we said, like, we have a couple of ideas how we can help you kind of solve these problems. So first thing, cloud native transformation, because that sounds nice, and you can put like 10,000 euros more on the bill. So for quality assurance, what we suggested, how about automated testing? Which sounds pretty straightforward and kind of obvious, but I think they didn't really think about, oh, okay, maybe there is a way to test things automatically, like not with humans, not with humans attached. There's a way to do that. And yeah, it sounds weird to maybe us because we're kind of like, we grew up or we're more familiar with modern software development, but I mean, this was a bank. Like people were there for like 20, 30, 40 years. So, I mean, there was a pretty straightforward thing that we suggested. The other thing for the diverting environments was, okay, I mean, you hired us, we're the Kubernetes people, Kubernetes. In this case specifically, technically what happened was that Red Hat went into there and they were like, oh, we're doing OpenShift here now, which is the proprietary version of Kubernetes that's owned and maintained by Red Hat. How about you hire these people because they know Kubernetes? So it's actually the other way around. We did not suggest OpenShift to them. They suggested us to the bank. So through using Kubernetes, we were hoping that we could deploy to all the environments in the same way, and thus the environments would not be diverging as much. And then finally, to help with the compliance aspect, we were suggesting to do GitOps. I'm going to explain a little bit more what GitOps is, but I guess like most of you are kind of familiar with the idea. So just to say right now that we suggested GitOps should be the solution to solve the compliance question. And they said, yeah, sure, let's do it. Let's do like a 1-year contract, and you can build up this GitOps platform. So we set out to introduce GitOps to this company. And just quickly, in case you don't know what GitOps is, so the idea is you have a Git repository that stores the config of your environment or of your application. It can be Kubernetes manifests. It can be Helm charts. It can be a Docker Compose file. It can be, I don't know, Ansible. It doesn't have to be Kubernetes, technically. It's just like a way to declare the state of your application. And then what you also need is some kind of environment, probably some kind of server, that hosts and runs your application. And that is somehow kind of connected or synced to the config repository. And then in between those, you need something to orchestrate, to kind of install and manage the lifecycle of the application on your environment. And in our case, that was Kubernetes. But as I said again, technically, to do GitOps, you don't technically need Kubernetes. What you need is something that you can declare your desired state to, and that will then make sure that whatever you declared will eventually happen on that environment. So, to kind of talk about what exactly we were doing there, we need to take a look at how this all looked at the very beginning. So, beginning of time, when we arrived there, this is how the delivery pipeline looked like. So it would start with the PO, the product owner. They would request some kind of feature. They would probably just go to the developers and say, like, I want a button. Bless you. And the developers would then pick that up, and they would like implement it and maybe test things, and sometimes they would write unit tests, and sometimes they just wouldn't. And once they were done, they would merge the changes to a release branch. So at that time, we still had like release branches that I think the oldest one that I saw was like 8 months old, and that was still active. So they would merge the changes into this release branch, and then there was a person called the release manager, and the release manager was not its own like job title per se. It was just like someone had to be the release manager. That could be the lead dev, that could be the PO, that could be just some poor guy who was walking around the hallway, you know. And that person had to now build the artifacts from the release branch, deploy that to the dev environment, and maybe test some stuff and then improve those changes. And as you can probably imagine, I think some people were laughing, this is not a very thankful job, right? Because suddenly you now are building and deploying and testing the changes of like 8 months of work, and it's also signed with your name. Like if you do GitOps, obviously there's going to be a name on it, so it's not a very nice job to have. Once you approved everything, you're like, okay, this works now. You can deploy the stuff to the staging environment, which again, slightly different than the dev environment, which is like big points of contention. And you would then call the PO, or if you were the PO, you would just call yourself and say like, okay, I've put everything on staging now. Please go and test whether this is actually the stuff that you requested, which, as you can imagine, again, sometimes led to like, oh, this is not the stuff that I requested, and you have to go back to like 6 months ago. So the PO tests and approves the changes, and then they go to the ops team, and they're like, hey, I have these artifacts from the release manager, and please can you deploy them to production? So this was the delivery process, and I'm feeling like maybe you are familiar with that kind of general process of delivering software. We've done it not too long ago. I know like there's a former colleague of mine here, and I remember that what we did was like not too far away from this, and that was like 6 years ago. Right, so one of the first things that we did, we looked at these jobs that I circled here, and we were saying, okay, the release manager is obviously something that no one wants to do. Let's try and get rid of that. Let's try to automate that. And like the bluish, greenish stuff, so the first two, building and deploying to dev, that was kind of already almost automated because those were scripts that just someone had to click a button or like execute. And the yellow reddish ones, they were like more manual because staging was so weird, right? And then testing and approving is something that's just easier if you do it manually. Or so you think. You would think that that's easier intuitively. So what we did was we, as I said, got rid of the release management role and instead automated that. So the way that it would look now is that, again, PO requests a feature, developers implement, test, merge to the release branch, and then once you merge to a release branch, that would automatically trigger a job. Don't ask me where, but it would trigger a job that would build those artifacts. Again, there was already a script, deploy to dev, and then run our automated tests. And you're like, wait, when did you get automated tests? Yes. I should have probably mentioned at the beginning, this was a complete greenfield project. So everything was completely new, so we forced everyone, if you want to come to our platform, you have to have automated tests that we can execute. That worked reasonably well. I mean, people wrote tests. They were not the best tests, but they wrote them, and that's enough. So once those tests were green, okay, changes are approved, we then would deploy to staging, and remember, we're now on Kubernetes, so we can use the same deployment mechanism now for development and for staging, kind of automated. And then once that was deployed, I don't know, I think some email went to the PO, and they would then, again, test and approve, and then call the ops team to deploy to production. So it was kind of like the same process, but we just like, the scripts that already were there, we just like made them fit more seamlessly into each other and trigger this automatically. So the way that we built the architecture was we started with a repository that was the source repository. This is where the source code lived in. And it would trigger, that would have a Jenkins pipeline there. And whenever you merge to the release branch, a Jenkins pipeline would start, and it would do two things. It would build the artifacts and put them in Sonar. Yes, Sonar Cube, I think is the name. It's been a while. And the second thing that it would do is it would copy the Kubernetes manifest into the configuration or the GitOps repository. So that means that the actual manifests were living in the source repository, and we would just always copy and paste them to the config repository. And that would be then connected to the Argo CD that was living on a dev cluster, and would then just constantly sync with it, and then put the changes onto the cluster. And technically, you could do that all the way to production. We haven't done that yet, but the idea was like this could just be the same way from development to, there were like two staging environments and then the production environment. And the nice thing about this is that because we're copy-pasting the manifest into the config repository that actually is the repository that is applied, the developers can decide, they can build this manifest, but then the ops team could then override things with their own resource limits and network policies and all those things. So this was the state that we had after about 8 months or so. And we were looking at the deployment to production because, as I said, theoretically, we could do it all the same way, right? Like, theoretically, we're on Kubernetes now. The only reason why we didn't do it on production was because it was production. And obviously, again, you want someone responsible. You need someone's blood. If something goes wrong, you can't just be like, oh, it's an automated system. You just have to be able to fire someone. So we knew that we couldn't change that because, again, this is like a bank, right? You can't just reason with these people, right? So instead, what we said, okay, how about this? We do the deployment automatically, but the ops approval can still be manual. So what we did was we worked with pull requests at that time already, right? Like Git, why wouldn't you use pull requests? And what we did was once the PO has tested and approved the changes, they would open up a pull request to make those changes to the production config repository. The ops team could just approve that pull request, but the actual deployment would then be done automatically by Argo CD, which makes a lot of sense. But again, I don't think they were thinking about I think the idea is just that for a lot of people, they think that it's better for humans to do things because that's less risk. But the truth is it's often the opposite because machines are, at repetitive tasks, tend to be better than humans, tend to make less mistakes. So it just worked, I don't have to tell you. I mean, you're all engineers or engineering adjacent, so you probably know that if you let machines do things, a lot of times it works. So yeah, management was super scared that we would see more bugs in production because of that. Surprise, surprise, we actually saw less. So we were feeling pretty good about ourselves at that point. It was maybe about a year. And we were like, okay, we solved all the problems, everything's awesome. But it turned out we didn't. It turned out we kind of saw older problems pop up again. So one of the things that we were seeing was that there are still things that are slow. And I don't know if all engineers are like that. I mean, I used to be an engineer as well, but you make improvements, but you still see all the things that don't work, and it pisses you off. You're like, I'm already doing kind of like a CI/CD-ish kind of thing, but it's still so slow because of these tasks here. Oh, let me see. Where's the? Okay. Well, the ones that I circled in red. I still have to do all those things manually, and that slows me down. So the things that I circled in red, those were the things that we were thinking, maybe we don't have to do that manually. Maybe there's a way to automate them as well. It seems maybe at the beginning, oh, we have to still test and approve manually because the PO is still needs to verify that this is the thing that they actually requested, and the ops team still needs to manually approve. But actually, what we were thinking is maybe you don't have to do it completely manually. So what happened was there was another consultant and me. We were sitting, having a beer, obviously, because that's where you always get the best ideas, that and toilet and shower. So we were sitting there, and we were talking about how can we make it better for, or easier for the non-technical stakeholders, the people who actually had to like check things. You know, there were like salespeople in there and management in there who just had to agree that, okay, let's do the release actually, like actually bring this feature out to our customers. How can we make it easier for them? Can they not just like go to the pull request and say like, yeah, it's okay, let's just merge this pull request? And the other consultant was like, no, we can't do that. They don't read pull requests. They are not able to read a pull request. And I'm like, yeah, but they're able to read a Jira ticket. And then we looked at each other and we had this like, are you thinking what I'm thinking moment? And then we're like, awesome, let's come up with a good name for it also because we need marketing people on this immediately. And so we came up with ReleaseOps, which is now the idea that I'm gifting to you. And you can put it on Twitter or like in your marketing department. I'm totally fine with it. But this is the idea that we're tying now the delivery or the process to releases rather than just deployments individually. So the idea is the following. There's a new shiny automation lane now. And what happens is now the process starts with the PO requesting a feature. That's still manual. That's why it's red. It will probably always be manual for now. And they will now create a Jira issue. And that's the Jira lane now. So they will create a Jira issue, and once the issue is created, it will automatically inform the development team, hey, there's an issue, please do things with it. The devs will implement and test it. That's red because I think for now we still need to do that manually, although I have looked at GitHub Autopilot, and it might not be too long until we don't need each other anymore. Anyhow, so the developers will implement and write tests, hopefully. And they will be like, okay, I'm done, I've tested everything, everything's fine. I'm going to put this issue into in deploy now, in deploy state. And once that is done, that will automatically merge the branch, the feature branch, into the main branch. So we're already doing CI/CD, or more CI/CD than we did before, because we're not using release branches anymore. That was a long discussion that we had with a lot of people to stop using release branches. And then, so this is all, we've already seen that. This is all the same automation that we saw before. So once we merge to the main branch, we build, deploy to dev, test and approve. It says deploy to test. I don't know why. I'm sorry about that. Deploy to, just ignore the middle ones. Deploy to staging, and once we have deployed the changes to staging, that will automatically trigger the issue to move to a state called in review. And once we're in review, it will now prompt the PO, it will notify the PO, please test the changes, make sure that this is what you actually requested. And at the same time, it will also notify the ops team to say, hey, these are some changes. Can you please make sure that this won't break anything? The PO and the ops team both need to approve those changes. And the way that we actually implemented it was that the PO basically just like commented into it or like said a thing, whatever, but the ops team were the actual owners of the approved column. So only they could actually move the ticket into the approved stage because we just decided it's more important that the ops people agree. And then once the ticket was moved to approved, that was the moment that we then would do the actual deployment to prod, which was again automated. So as you can see, most of the stuff is more or less automated. Even though it has human gatekeepers, it's still like the actual process of it is automated, which already cut down on a lot of accidents and mistakes. So the architecture here is kind of similar to what I've already shown you, except that now I'm using some brand names. So we start with the Jira issues. By the way, they bought the Atlassian suite, so we just used that. And I know some people don't like it a lot, but the nice thing about the Atlassian suite is that they're like Apple, right? They integrate very well with each other. Not so much with other tools maybe, but like with each other, it was super awesome. We used Bitbucket, and it's super easy to like make Jira tickets open and close branches and pull requests and all of those things just from inside the ticket because it all works seamlessly. So we had this app repository still, as before, with the manifest in them. And we had a pipeline that would then, again, build artifacts, put them into SonarQube. By this time, we now had a management cluster, so a cluster that would only do like global managing of other clusters. This pipeline was now Tekton, because Tekton had become part of OpenShift, because we switched from OpenShift 3 to OpenShift 4. And I think they call it OpenShift pipelines. I don't know, ask the Red Hat people here in front. And yeah, the second job, again, the pipeline was building the artifacts and also putting stuff into the dev config repository that was connected to Argo, same as we saw before. So it's just, again, it's just some brand names have changed. So we built this POC, basically, so that we had like a little service living on the cluster that would actually make sure that if you move something here, it will just monitor that everything was going to the right direction. And it was about like 1 year, 7 months or so, when Corona hit. And one of the things that always goes first when you're in a crisis is that they cut R&D completely, so they were like, maybe you should just leave now. From what I hear, they did go with the idea of it. They changed a bit of the architecture, but then generally the idea of tying your delivery process to the releases rather than deployments, they stuck with that because it worked really well. Or because management just said, we want to keep it like that. And because my time is running I'm almost there, I just want to leave you with like a final thought by Kelsey Hightower, who says that he's convinced the majority of people managing infrastructure just want a platform as a service. The only requirement is it has to be built by them. And I think that's kind of very true, because in the end, what we built was nothing that was new. Like nowadays, with the rise of the internal developer platform, I've seen a lot of stuff that we basically did for them. We said we were setting out to build a GitOps platform, but we kind of like did much more than that. There was like some self-provisioning of namespaces, of cert managers, of, I don't know, all kinds of stuff that went way beyond GitOps and just delivery. And because I said I have to talk about this because someone has to pay for my trip here, I'm going to show you like a quick 30-second video of the company that I actually work for, because what we do is kind of like an internal developer platform. We have this product called Loft that builds on top of a couple of other open source products, including vCluster. And what it does, and I think it's very small, so you probably can't see it very well, but what we do is that we provide you with the ability to create virtual clusters on top of your Kubernetes cluster that will allow you to do multi-tenancy very easily, and you can install, let's say a cert manager on your host cluster that you can then share into the virtual clusters, or you can install stuff into your virtual cluster that is then isolated from the other virtual clusters and your host cluster. And you can manage everything on there, like your apps, your secrets, your whatever, and it's just super cool, and you should check it out because it's for free. Well, if you're one person, if you're more, then you have to pay for it. But as I said, it's built on open source products that are completely for free, obviously, and I encourage you to check them out. And that is the end of my presentation. Thank you very much.
Thank you so much, Lian. We've got 3 questions already, which is awesome. Just a reminder that if you are in the app, to select stage P1, and you can ask your questions too if any come up. So let's begin at the top. Was there at any time only one single feature developed? In other words, how did you deal with conflicting PRs?
Was there anyone? So yes, there was. Once we taught people to request features correctly, they did manage to have like one feature per release. Conflicting PRs during the process, I'm not quite sure if I understand correctly, but basically when there's merge conflicts or when there's actual like logical conflicts, I guess. I mean, merge conflicts just like the product owner or the owner of the code just has to decide, like, we're going to apply these changes, and these have to go back to the idiot who made them. I don't know. When it comes to logical stuff, because there was only one product owner per section of the software, so I don't think that was a big problem. The other thing we did was using feature flags. So you can, if it's not code conflicts, you can deploy them and then just never turn them on, which also happened a lot, actually. Not something that I would recommend, but yeah, I hope I answered that question. Otherwise, maybe restate it, and I will try to answer the correct question.
Okay. In your opinion, can GitOps also manage other documents like documentation or compliance sheets?
It can. Oh, funny story about that. So the way that this company actually managed their compliance sheets and their delivery for a while was through IBM Lotus Notes, which was a lot of fun.
Old school.
It was really like coming out of the 90s. I would not do it. So, I mean, I guess you could, but why would you manage, unless you're managing everything through GitOps, then it would maybe make sense, but why would you manage a compliance sheet with your software? That doesn't really make sense to me, and I wouldn't do it because GitOps is really good for, like code stuff, like Kubernetes manifests and like source code. It's not ideal for like things that people want to read, or like, that's useful for people and not for machines. So I wouldn't recommend it, but I guess you could if you wanted to.
Thank you. All right. After implementing your first CI pipeline, what was the difference for the change failure rate?
What was the difference for the change failure rate? I don't have a number. I can't tell you the numbers. I think what the thing that I think was most important for people to understand is if you start using a CI pipeline and you start using it more often, it will build trust in the systems. The more often you use a system, the more trust you will gain into it, because you'll see it fail less. If you do a thing once every 6 months, like before in the past, they would just deploy once every 6 months, and it would fail. Then it failed 100% of the time, or like 50% of the time. But if you use it like twice a day, and it fails once every 6 months, then you just gain the trust in it. And I think that was the main thing. Again, it's like people believe things that are not necessarily true about machines and like the relationship between machines and humans. And I think that was the main thing that I would say.
Okay, how have the automated tests evolved?
Terribly. So actually, I think the Aqua people are here, so we were using Aqua as well. They have, so the automated testing did not go super well until we discussed how about we just get rid of the QA team. And instead, we embed the testers into the development teams, so we could actually do test-driven development. Maybe write the test at the beginning. Maybe first write tests to have the specs, and then write the code. It's like, again, very novel idea. And we were discussing that, and one day we came to work, and then they were just gone. The teams were just like, okay, we're mixing all the fucking teams. Oh, sorry. We're mixing all the teams, and you're now in this team, blah, blah, blah. And then it went pretty well. The QA team was not happy about it at first, but then the tests looked better.
Okay, and how about rollbacks?
Oh, you don't roll back. CI/CD, you don't roll back. You fix forward. But also, we built a very hacky thing that, like, where you could basically have a revert as a commit and then there was like a fast lane. I know, I was telling you about like, oh, this is a nice process, and then we were like, ha ha ha, but like, what if there's a big red button where you actually can do the thing that no one's allowed to do? Again, as I said, it's a bank. You can't reason with the people. You can't be like, oh, but like technologically, this is the better solution. But they're like, yeah, but what if like things break and there's like a, people lose their money, then you have to. So yeah, rollbacks were revert commits that we would pipe through a fast lane that wouldn't go through all the environments. But then again, someone had to sign with blood that it's not going to break more things.
All right. Well, thank you so much, Lian. That was really great.
Oh, one more thing.
Yeah,
if you're interested, going to karaoke tonight. So find me at the party, and we'll
yeah,
head
I saw
out.
it. Your Twitter profile says what? Chief Karaoke Officer.
That's my day job, actually.
Amazing. All right. Thank you so much. And yeah, have a wonderful conference, everyone. Thank you.
Thanks.
Lian.